All right, so are you still you're still there, right? Okay. Why don't you step out? That'd be great. All right. He stepped out. Okay. Cool. Yeah, I'll have to make the test slightly different anyway, but I won't upload this until he's taken the test. And okay. So I've got the test up here, and I'm recording, and so you can work your way along. And so the video will have the test, even though you're not getting back the actual test unless you happen to keep it. All right. So, what function should a GIS have was the first one. The correct answer was E. Does it mark the correct answer on there? No. Okay. So you'll have the version there. I scanned all your tests in, so I'm not worried about. Like maybe if you came to me and said, "Hey, I erased this answer and filled it in, and the computer didn't mark it correctly," then maybe I can take a look and see. But anyway, off the topic just slightly. So the correct answer is all of the above. So GIS, that was Keith Clark's definition we went over the first day, was that it could do data entry, editing, data management, analysis. Those were all things that a GIS could do with spatial data. So the correct answer was all of the above. And that was the answer. All the questions are with the same because it's multiple choice test. All right, let's go through this a little bit faster, I guess. The next question: in a GIS, similar data is often organized into layers. That's the correct answer. So C. 3, true or false? We understand a GIS to be a computer-facilitated system, but GIS is not only software and hardware, and that's true. It also includes the people. We said that the first day I was in the book in the lecture. Number 4, GIS data must contain which of the following types of information? And the correct answer was spatial coordinates for it to be GIS data. The other ones are speed limits, elevation, blocks, none of the above. The spatial coordinates was the correct answer. They don't have to be, they can be latitude, longitude, or they can be in some projected coordinate system, but they're still spatial coordinates either way. Number 5, an ellipsoid is, the correct answer is C, a mathematically derived surface that approximates the Earth's shape. The only thing really wrong with B is that it's not a sphere, it's an ellipsoid, so it's not spherical shaped. A describes a geoid, which is not the same thing as ellipsoid. And then D was just something I threw in there with some words. E is none of the above, and C is the correct answer. So E is not correct. Number 6 is F. Datums are designed for the entire Earth and only need to be changed because the Earth changes and measurements get better. That was false. So the reason that it was false is that we did discuss that the datums and the ellipsoids that they're built off of are sometimes designed for a specific area. They model the Earth only in one portion of the Earth. So although the instrumentation and the Earth does change, that's true, it's not the primary reason that additional datums are designed. So that's false. What is the most likely position of the city of New Orleans? The correct answer was C there. This is just like a general quiz to make sure that you understood latitude and longitude and how it's referenced. So knowing where the zeros are on both was what you needed to know. Obviously, it's not in the southern hemisphere, so that question's not right. That question's not right. That answer is not right. It's not in the eastern hemisphere, so that answer is not right. And then the other two coordinates are backwards. One contained an east and a west, and a south and a west. All right. Latitude and longitude report angles from the center of the Earth, B. Number 9, defining a projected coordinate system requires units, ellipsoid, and a surface. How it ties to the developable surface. All of those. So D is the correct answer. Distortions on a map due to map projections fall into the following categories. The correct answer was B, area, distance, direction, and shape. That's the right answer. Oh, I should be progressing here. I'm reading from the paper. Should be progressing like this. Okay. So 11, this is true. Map projections attempt to balance distortions and minimize an error in an area of Earth for which they're designed to cover. That's true. So sometimes they could be for the entire Earth. They attempt to balance the distortions for the entire Earth, or they could be very specific, like UTM zone for just a portion of the Earth. Number 12, the distortion for an area would be greatest for which of the following areas if mapped using a UTM zone 16. So this required a little bit of understanding in regard to this required a little bit of understanding of coordinate systems and how the UTM coordinate system is set up. And so the correct answer is B. An area in New Mexico would have the largest amount of distortion. So zone 16, and I gave this, includes most of Mississippi. In fact, it's the eastern part of Mississippi and some of Alabama. And so the UTM zones run north to south. They're long and thin this way. So the further you got out, you did this in a lab, the further you got out from those UTM zones, the worse the measurements were, the more distortion there were. However, traveling north to south in the same UTM zone doesn't cause those same. So Illinois is roughly north of Mississippi, and so it would have less distortion than going all the way to New Mexico. An area in Alabama would be similar. In fact, some of Alabama is even in that same UTM zone, most of Alabama. So the correct answer is B, because it's the one that's furthest away. All right. If I wanted to map the entire state of Mississippi using the same map projection, which choice would be best? And here the key is the entire state of Mississippi. So neither of the state plane coordinate systems would be the best because they each are good for their portion of the state, but they're not good for mapping the entire state. UTM Zone 16 likewise runs through the state of Mississippi. So the correct answer is the Mississippi Transverse Mercator, which is what we use a lot in the state of Mississippi for statewide projects. All right. 14. Which data model is based on a regularly spaced set of values over the surface of the Earth, and that represent values at those locations? For example, elevation. That's the raster. C, the raster data model. Which data model is uses? Sorry, there's a little bit of grammar error there. Which data model uses points, lines, and polygons to model real-world features in GIS data? And that is vector, A. Which of the following is a file format for vector data? JPEG, IMG, TIFF, or GeoTIFF are all raster data formats. They basically images. So D is the correct answer. E is not correct because D is a correct answer. Shapefile. We used shapefiles in this course for most of the labs, and they were vector points, lines, and polygons. Which data model is better suited to support topology? So topology, the definition of that was spatial relationships between entities in the real world. And although not every vector format supports topology, it's the one that's best suited to do so. So A is the correct answer. TIN and raster don't really do it. Topology is not the name of a data model. It's just thrown in there. All right, 18. GIS data typically includes at least two parts, which are the coordinates and the attributes, B. Vector data models do not support topological relationships, such as shapefiles are said to be spaghetti. Spaghetti is the correct answer. Spaghetti data models, mostly the reason that they use that term is because you drop spaghetti on a plate, and each line can be one on top of the other. Okay, number 20. Although GIS data is often considered scaleless, and we talked about that, zooming in, zooming out, you can display data at different scales. But basically what's the problem with that is that the grain size is the correct answer, meaning that as I zoom in and zoom out, sometimes that data may be less precise. It may not be precise enough to use at a certain scale because of its grain size, and that's what the book used to refer to that. Probably also would have accepted spatial resolution. That's the term we usually use in like remote sensing literature, but we didn't use that term that often, so I left it off to not be confusing. Number 21, which of the following was not given as part of a complete map in the lecture? Was not given as a part of a complete map in the lectures. And so the answer there was A, Great Line. The other ones were all there. Which term below is the ratio of a distance on the map to a distance on the ground? And that answer is scale, the ratio of distance on the map to distance on the ground, scale. True or false? Larger scale maps cover less area, but show more detail. That is true. Larger scale maps cover less area, but they show more detail. In other words, they're maps of, given the same size on a piece of paper, they're maps of a smaller portion of the surface of the Earth. Number 24, what is the term for the area covered by a particular data set or map? That's the extent. In the georeferencing lab, we created vector lake data using imagery. That's one of the labs we did at the first part of the course. Remember, we drew the lake polygons. That process is called digitizing, which is A. Which of the following is not a problem or a source of error in manual digitizing was the right thing to put there? So it's the answer from the previous question of existing maps. So this was taken from the lecture notes, which was taken from the book. So I have choices there. And then C was tracing the location of important coordinates. 27, GPS systems the GPS system has three segments, which are the control, the user, and the satellite, C. Which is the closest to the number of satellites in the GPS constellation? Although, like I said, even in the review session, there was some discrepancies, but it was closest to 30. And I didn't put a none of the above just to make sure that wasn't, the closest one there is 30. At different times, there's slightly different number of satellites. There needs to be at least 27 in the constellation in order for it to work. Okay, a GPS receiver needs to receive a signal from at least 4 satellites to report a 3D position. That's the answer. That's B. A GPS reports a position based on the position of several satellites and calculates the distance ranged from each. So that's the correct answer there, A. It's not angles, although it probably could calculate those angles once it's calculated the range. It works through that principle called trilateration. Okay. Number 31 is true. High PDOT means a smaller area of positional uncertainty because the satellites are widely spaced. No, sorry. I should have read my key. It's false. It is false. I was jumping ahead. I just read it. So low PDOT means a smaller area of positional uncertainty because the satellites are widely spaced and visible in the sky. So it is true that widely spaced satellites yield a smaller positional uncertainty, but that makes a low PDOP. So that's why that one's false. All right, multipath error is caused by, and this one is letter E, the signals bouncing off of other objects before reaching the receiver. The reason why it's not D is that the mountains blocking this. In other words, what I'm trying to say there is multipath is not caused by any signal not reaching the receiver, which can happen a lot, particularly where we live. We don't have mountains, but we have big, tall pine trees. And in those cases, the GPS, if the signal is coming from too far away or too low in the horizon, the pine trees will block that signal. Actually happened to me yesterday. I was collecting some data. Okay, number 33 is differential GPS results in better position, but requires at least a number of GPS receivers. Okay, that's 2. Differential GPS requires a radio link between the base and the rover in the case where the post-processing is utilized. The answer there is false. You can have a link, which will give you a real-time differential, but you don't have to. All right, 35. In georeferencing, in what ways does first-order transform adjust the target or unreferenced data? So this was also related to that the digitizing and then georeferencing lab. The correct answer is A, translation, scale, and rotation. In other words, it rotates it, moves it, and stretches it to the proper position, but it doesn't distort the image at all in a first-order transform. Number 36, in georeferencing, the RMSE statistic is measured in whatever units the map projection you are using is in. So E. 37, what are the characteristics of good ground control points? These are all, I've just basically copied and pasted most of these from lecture notes. The correct answer is all of the above. Okay. True or false, the root mean squared error is measured used in georeferencing to express the differences between the values predicted by the model and those selected at ground control points. That's true. It's used to give you a measurement of that error. Number 39. Okay. What important question do you need to ask using existing digital data? That is E. They're all important questions. Extent, grain, and attributes. That was, I think, the first or second slide that day. It was on the review sheet as well. What nationally available data set is distributed by the U.S. Census Bureau? This is the Tiger files. Okay. E. Which U.S. Census map scale would have the least number of maps for a state? So in other words, you had to know how large these maps were, how much land area they were. So the one that has the largest number is going to have the least number, because in reality it's 1 over 250K, so it has the smallest number. It's the smallest scale map is another way to say that. 42. Which nationally available data set of scanned and georeferenced USGS quadrangles? That is the scan and reference of digital raster graphics. That's what the key says. 46, the HUCs, where are they found? The HUCs are found in the National Hydraulic Data Set. Which is the largest of the census divisions in this list? That's tracked. I realize that might be a poor question. Because, it says which of the largest is the listed census. Probably shouldn't have included none of the above, though. So anyway, which database refers to a general variable or term? And that is a column in a table, so that would be an attribute A. Let's see if that's what I put down. Yep. Okay, 46. Real-world entities or objects represented in a GIS database are are rows, columns, tables. Real world objects are rows, A. Those are both A. Which records would be selected in the following table by the following query? Population is greater than 8,000 and area is less than 8,000. So which one has population over 8,000? This one, and that's it. And they also have to have area less than 8,000. So that would be just 4, because that's the only one that meets both of those criteria, because that's and. So that's only 4 is the correct answer. Which table operations will I use to create a new field and calculate the population density from existing population area fields? That's calculation and assignment. In other words, I create a new field and then calculate a value based on an existing field. We discussed that, and you practiced it several times in the lab. Which fundamental database operation combines 2 tables, top to bottom? That is top to bottom is union. 2 tables side to side by a common key would be join. In a table, knowing the value of an item or items means you know the values of other items in the row is a functional dependency. I said that we weren't going to make you memorize all the different types of functional dependencies, but just recognize in general what the term means. So that's the test question on that. All right. So anybody have any questions on that? If you're more comfortable like coming to me one-on-one or email, that would be fine. Let me close that down just so that we can invite the other student back in. So somebody down there, go open the door and say, come on back in. While you do that, I will. That took longer than I thought. Sorry. Maybe I should next time. Maybe I'll just make a video of it. All right.